Hello guys, this is Raghav and today I want to share with you my complete roadmap on how to become a DevOps engineer. Whether you are just starting out as a fresher or you're already experienced in engineering and want to get into DevOps now, this is the right roadmap for you. And if I was starting all over again, this is exactly the plan I would follow. Right out of college, my first job was as a site reliability engineer at a startup. And I loved my job so much, I never wanted to go back to backend engineering. So for the last 7 years, I've been a DevOps engineer as well as an SRE. I have worked at startups as well as large enterprises. And in my roles, I have built CI/CD pipelines, logging solutions, backend applications, infrastructure, SLOs for critical systems, observability for microservices, fixed bugs in massive Java code bases, saved companies hundreds of thousands of dollars in infrastructure costs. I also cried a lot. That's part of the job. So naturally, I've used a wide variety of tools like Docker, Kubernetes, Jenkins, Terraform, Prometheus, Grafana, Ansible, all sorts of AWS products, Python, Golang, and the list goes on and on. I've had a lot of successes and a lot of failures, and they all taught me very valuable lessons. But if I could start all over again, I would have gotten here much faster because now I know what works and what doesn't work. So here is my roadmap for all you people who are hungry for the DevOps pie. It will provide you a solid path right from the fundamentals up till the expertise. And for each item, I'm going to challenge you to build a project which will help you understand its concepts better. So this is going to be an insanely valuable video, so make sure to watch right till the end. Let's get started. So this is you, right here. You have everything that it takes to become a DevOps engineer. You just need a little direction. So the first thing I would do is to get good at programming. You might have heard that people are often screaming that, you can't become a DevOps engineer without first being a software engineer. While I totally disagree with that because I myself became a DevOps engineer as a fresher, I do agree that you need programming experience. You do need practical software engineering skills before you can dive into DevOps because you need to understand the dev part of DevOps. So at the very least, you need to know Python. You don't need to be an expert, but you do need to be able to write decent software and scripts in Python. For example, you should be able to build a REST API, a backend API in Python, or write a script which can analyze some logs and produce some reports for you. You should be able to understand what is object-oriented programming, and you should be able to tell the difference between compiled languages and interpreted languages and when to use which one. Try writing some C or C++ code, build some applications in it, and learn how memory management works in these. Understand buffer overflows, memory leaks, and how to use some good practices to avoid these things. Then go and get some practical experience as a software engineer. Okay? You can take up a job, you can take up an internship, you can even contribute to open source code out there, right? There's plenty of projects, big and small, and they're very welcoming to people who want to contribute to their projects. So go look at their documentations and try contributing. Start small and go bigger in terms of contributions. And you can also pick up freelance projects. You can go to websites, pick up small projects, then slowly bigger projects, and it'll give you lots of practical exposure about how to solve real problems. So for example, you should be able to build a complete website end to end, front end, back end, set it up on infrastructure, publish it, all these things. So end to end website development, you should be able to do. I did all these things while I was in college, which is a big part of the reason why I got DevOps as a fresher. Now, the next thing I would focus on is to get good enough at data structures and algorithms. If you've watched my previous videos, you might have noticed that I'm a very anti-DSA person. I think that beyond a certain point, doing data structures and algorithms questions is just like a complete waste of time. I would rather that everyone focuses on solving real problems instead of doing more lead code questions. But I do highly recommend that you get at least some exposure in this entire field. You need to know the basic data structures and algorithms and how they are applied in the real world. For example, most popular programming languages out there manage their memory using stack. Similarly, if you have ever heard of Amazon SQS, Kafka, or RabbitMQ, at the heart of all these tools is a queue data structure. You should be able to implement your own binary search algorithm and understand why it is so much more time efficient compared to a linear search. Understanding big O notation, space-time complexity, being able to reason about different trade-offs and which algorithm to choose in which situation, these are all still very important skills that you need as a computer scientist. So learn these things, spend some time doing lead code questions, even go to medium or hard, whatever you like, but give yourself a timeline. Like, I would personally not spend more than a couple of weeks over here, like let's say 6 to 8 weeks. That's what I would give myself. And at the end of it, I think it would be sufficient to move on to solving more problems. It teaches you problem solving skills, analytical thinking, how to work within your constraints, breaking big problems into much smaller sub problems, and so much more. So pay close attention. And once you're done with this, start learning about operating systems. Now, this is where, for the first time, you will start diving into the DevOps territory. Operating systems are often the first layer of software running on every piece of hardware that you'll ever work with. Web servers, supercomputers, IoT devices, your personal computer, everything has an operating system running on top of it as the base platform, and all your other applications are deployed on top of that operating system. So it is absolutely essential that you understand how do these operating systems work. For example, what happens when I press the power button on my laptop? How does the operating system get loaded into the memory? And how does it load a GUI or a command line interface onto the screen so that I can start interacting with my computer? How does your Python code get executed by all the tools that your OS provides? How are all the resources managed? Hard disk, CPU, memory, network. Then how is your operating system running multiple applications at the same time? Can you tell me the difference between concurrency and parallelism? And then what is virtualization? Like, how are you able to run multiple operating systems on top of the same given hardware? And you don't need to know every bit of low level detail on these, but you need to understand the general process, how these things happen, right? So that if someday you have to troubleshoot it, you know where to start looking, and then you can dig deeper. Then, once you have a good fundamental knowledge of operating systems, you need to dive specifically into Linux. Because no matter where you go, no matter what you're working on, chances are that you'll be running Linux across your infrastructure. And you will be doing a lot of debugging inside your systems. So it is crucial that you know your way around Linux. For example, what are the important root directories in Linux? /proc, what does it do? /tmp, what files does it contain? Where do all the executables in Linux live? Then how do you read system logs from Linux? And how do you schedule cron jobs in Linux? Do you know how to work with bash, and can you write shell scripts to do some basic tasks? Can you use the command line to get more information about your system? Can you use it to change firewall settings? And let's say you want to know which application is currently bound to TCP port 8000 on your system, because there is something running on this port and you're able to make requests to this port to get some response, but you need to understand what is the application that's running, because it could be a malware. So can you do that? Then how does Linux manage disk partitions? What are disk partitions to start with? And how does it efficiently manage memory? What is the concept of paging and what is the concept of virtual memory? Also learn at least the basic usage of Vim, because oftentimes you're in server environments where there is no graphical user interface. All you have is a command line, right? Vim is one of the best editors out there to just simply edit all the files over the command line. And you'll often need it to edit configurations or just to examine them. Then, do you know what are system calls? How does Linux allow you to access the underlying hardwares and the underlying operating systems functionality? What is the Linux kernel? So that's why being able to work with Linux is a very crucial skill, because this is where most of your applications, your workloads will be deployed. And this is where you will spend most time troubleshooting things. And the ultimate project to practice Linux and to practice operating system concepts is something called Linux from scratch. This is a brilliant project which gives you step-by-step instructions on how to build your own Linux distribution, a minimal OS, entirely from the source code of Linux. You will learn every layer of the operating system, how Linux works, how does it load into your memory, how does it provide you with interfaces and then makes way for you to run your own applications, everything. So try building this. I've included the link in the description. Now, once you understand operating systems, once you understand Linux and how a single machine works, the next important thing to understand is when there are multiple machines, how do they communicate with each other? How do they talk to each other? And that's why the next item on the list is networking. Modern systems need to handle extremely large tasks like big data and handling lots of traffic on a website. And these things are so large that you can simply not afford to do them on a single computer. So naturally, you have to do it across many different computers. And that is where networking comes in. Networking is how all these computers talk to each other, they coordinate with each other, and you're basically in the territory of distributed systems. Networking connects all the computers together, and so as a DevOps engineer, you need to understand it. Because when two systems are unable to talk to each other, things start to break. So if your backend server is suddenly not able to talk to your database server, you are no longer able to read or write any data, and maybe because of that, you are no longer accepting any payments from your users. So your business is no longer making any money. And without a good understanding of networking, you will most likely not even have a clue of where the communication gap lies. So you should learn networking concepts. Things like what are the different layers of the network protocol stack, right? What is the difference between application and the transport layer? What is an IP address and what is a MAC address? Which kind of computer gets an IP address? Which one gets a MAC address? Why do they have both? All these things. Then what are all these different protocols like TCP, UDP, HTTP? What is the purpose of these? When do you use these? And when you are developing an application, which protocol should you choose? What are ports? Why do applications have to bind to ports in order to serve whatever they are serving, right? Why does HTTP always have port 80 and why does HTTPS always have port 443? How can I convert my laptop into a local web server? And then there's the infamous question, what happens when I enter google.com in my browser and press enter? Can you explain the entire story, end-to-end communication? And I know that all of this sounds like a lot, but the answers to all these questions that I'm mentioning here, they lie in some fundamental concepts of networking. So learn them. And then try a project. Try to build an HTTP API or try to build an application which allows two people across the internet to chat with each other. So learn networking because networking is at the heart of distributed systems and modern production systems are all distributed. Okay. Now, after networking, the next important thing is databases. You can argue that database is not strictly DevOps, but I will show you why it is. Even if you have a decent understanding of databases, you're good. You don't need more than that. How do you deploy a database cluster? Can you deploy it on just bare metal servers or on a cloud provider like AWS? Then how do you read-write data from database? How do you secure the data? Because the data you're holding in database is most likely very critical, right? And you don't want to expose any of this data outside. You want to be very strict about who is able to access this data, which application, which process, or which person. Then can you take backups of database? What are backup snapshots and how do you take them? How will you back up a database which is 100 terabytes in size? What happens if there is a disaster? Let's say your database is hosted in a data center, but suddenly there's an earthquake or there is a flood and that entire data center is just gone, right? How do you get your data back? And how do you set up a database in some other data center or in some other region, which is safer than your current region, and immediately shift all the traffic over there? So that comes under business continuity. These are all things that a DevOps engineer needs to be aware of. It is your responsibility to keep all this data backed up and reliable and consistent because the entire organization and your users are relying on it. So learn SQL. SQL stands for Structured Query Language, and it is the programming language using which you talk to many databases. Many popular databases like MySQL, PostgreSQL, all these use SQL, right? So how can you write SQL queries to read and write data? Do you understand ACID compliance? And when you're selecting a database, do you need ACID compliance strictly or not? How do you normalize your database? Then what are keys in your database table, like primary key, foreign key, and when do you use them? And then what happens if your monitoring alerts you that your database is totally saturated for memory, right? There is no more memory left in database or there's no more queries being processed in your database. So how do you go and figure out, is there any specific query which is hogging all the memory in my database cluster? How do you measure query performance and how do you troubleshoot when something is going wrong with your database? Then there is the infrastructure aspect of the databases. How do you, as a DevOps engineer, scale the database? When you're in a large organization that's writing 1 terabyte worth of data every day to your database, you can't store that kind of data on just a single machine. You will have an entire cluster of database which is probably spread across multiple data centers across multiple regions. So how do you scale that? You need to know how data replication works. What does it mean that you have one master node and then several reader nodes? And how do they read data from your master node? How do you shard the data? Because a single master node cannot take millions and millions of write requests per second, right? So you need to be able to distribute the write requests amongst multiple masters. So what is sharding and how does it work? Then how do you provide the underlying storage for the database? If the database is distributed, of course, the underlying storage, the disks, everything that you need to provide to it is also distributed. So what is network attached storage? And then finally, what is the CAP theorem? What is consistency, availability, partition tolerance? When do you need what? So learn these things, and the best project that you can do to understand database concepts is to set up your own DB cluster. So set up a new MySQL cluster, okay? A 3-node cluster where there is one writer node and there are 2 reader nodes, okay? Configure your cluster so that the readers are using bin log replication to read data from the master. And if you're feeling adventurous, also set up some cron jobs to take automatic backups of your database, right? And put these backups offline, like not on your computer, but on some other computer, on some cloud provider or something like that. So that if you lose your database, you lose your machine, you can still restore from a snapshot. Now, a quick note, if you are using a cloud provider like AWS to deploy your database or backup your database, that might end up costing you something. So make sure you understand your costs before you deploy such a thing on a cloud provider. Now, once you know all these items individually, database, networks, operating systems, it is now time to bring them all together with system design. Now, we all know that for a DevOps engineer, one of the most important interviews is a system design interview, and you need to excel at it in order to get your dream job. But it's not just about the interviews. System design is perhaps one of the most important skills that you need as a DevOps engineer when you're designing microservice architectures or you're creating a new feature inside a particular system. It will tell you whether your system will actually work at a large scale or not. It will help you identify bottlenecks. For example, if you have 5 servers running Nginx and your website wants to serve 1 million requests per second, are 5 servers enough to serve 1 million requests per second? Or do you need more? Or can you reduce the number of servers and still serve the requests and save on some costs? Another example, how much data storage we need to provision in our cloud provider so that we can retain our logs for 2 weeks, given that every day we are producing 500 GB worth of logs. So system design is all about designing a very efficient system that has best possible trade-offs and works in production. It ensures that you don't end up with $1 million infrastructure that just doesn't work. And as for the project, the best possible project you can do out of system design is to get a job at a big company and work with the systems deployed over there. If you want to practice your system design skills, there's plenty of courses out there. I would also highly recommend NALSD from Google, non-abstract large system design. But unlike a lot of other things on this roadmap, system design you can truly learn only when you have practical experience in the industry. So go and try to work on large scale systems. Now, when you're running hundreds of components in your infrastructure, VMs, containers, load balancer servers, database clusters, Kubernetes clusters, and God knows what else, how do you keep an eye on your system? Let's say your website is suddenly not accessible in the Asia Pacific region, or your users can no longer make a transaction on your website, so you are no longer making any money, right? How do you get to know which part of your system is problematic? So this is where observability comes in. Observability is all about having the complete visibility into your infrastructure. Whatever system you're running in production, do you have eyes on it? A DevOps engineer should be able to use all the pillars of observability, metrics and monitoring, logging, distributed tracing. They should be able to use all of these to drill down into the exact issues that are causing a certain problem. Because oftentimes, in terms of a problem, all you will see is that your website is not loading. But behind this website, there's like a network of maybe hundreds of microservices running on top of clusters, backed by databases. So you need to use these tools at hand to figure out where the actual issue lies. You should be able to configure your tools so that every time your MySQL writer node is down due to some memory issue, you get alerted and can immediately do something to fix it and avoid further damage to your organization. Some popular tools in this space are like the ELK stack, Elasticsearch, Logstash, and Kibana, right? Similarly, you've got Grafana, Prometheus, and Loki. You also have some SaaS solutions like Datadog, New Relic, and all that stuff. But regardless of what tools you use, make sure that you're a master of those tools so that when things go south, you know where to look, how to drill down and get the right root cause and then fix it so that that kind of issue doesn't happen again. One of my favorite projects in this space is something called Grafana Play. So this is a website from Grafana, which is basically a huge dashboard with lots of dummy data, which looks very realistic, which looks like you're monitoring a real production system. And the idea is that you've got all these things which are deployed in your infrastructure, and then you can play around with this data to figure out how to use monitoring tools and to figure out all the concepts behind monitoring. So set up some dashboards just to make your life easier, try setting up some alerts, and basically do whatever you want. Now, the next important item on my list is containerization technology. Now, although they are not fundamental to DevOps, containers and container orchestration technology is now so ubiquitous that every org, big or small, is either already using them in production or they are at least evaluating using them. That's because these tools make the lives of engineers so much easier when you have to deploy and manage hundreds of thousands of applications in production. So at the very least, I would definitely learn Docker. It is the de facto container technology out there with a massive community and a massive support base. You should understand the benefits and the use cases of containers, like when to use them, when not to use them, and how do you manage thousands or even millions of containers in production or in other environments, right? You should understand the basics of how process isolation works under the hood. Like what are the Linux features that containers use in order to isolate your process actually. Then do you understand the differences between containers and virtual machines? And then finally, when you have to manage thousands or millions of containers in production, how do you use container orchestration tools like Kubernetes? And by the way, I teach all of this stuff in my detailed Docker and Kubernetes courses, which are free. And I've mentioned their links in the description below. Do check them out. In these playlists, I teach you all the concepts you need to know about Docker and Kubernetes with plenty of projects and examples that you can do. So give it a try. Yeah. And I now have a special mention for AI. Now, unless you've been living in a cave for the last 2 years, you know that artificial intelligence has taken the world by storm. Generative AI tools like ChatGPT, DALL-E, Google Gemini, all of these are disrupting every industry. Every piece of work is being redefined as we speak, and so DevOps is no exception to that. So as a DevOps engineer, you can no longer afford to ignore the AI revolution. The ability to make AI work for you will give you a game-changing advantage in your career. It is the thing that will push you ahead of the crowd and faster. So learn things like prompt engineering. Learn how to use these tools like ChatGPT effectively, because things like prompt engineering will help you in every way possible. Coding, ideation, design, brainstorming of ideas, documenting certain things in DevOps, web search, not to mention that MLOps, the entire practice of running AI infrastructure in production, is a very, very lucrative career for DevOps now. And going forward, it's going to pay even more. So master artificial intelligence before it masters you. And now the last item on my long list is something which has got nothing to do with technical skills at all. It's called soft skills. So look guys, I'm not going to sugarcoat this. Being a DevOps engineer is not easy. It's hard. It's stressful. Jumping through layers and layers of software and infrastructure just to find a particular bug is fun at times, but it can also be frustrating at times. Being on call is also very stressful because many a times you have to wake up in the middle of the night to fix an issue which is bugging production right now, all by yourself. Probably nobody's there to help you and you don't know how long it takes, right? And then it ruins your whole night and then it ruins your next day. But on call is part of the job. So you've got to be good at managing your stress. You should know when to take your breaks. And this is a job that involves all sorts of moods. And you should definitely know when your job is no longer worth your peace of mind. So know when to quit, otherwise you'll end up burning out. Then another thing you need to be aware of is that you are working with other people in a team. You've got to be a team player, and you've got to acknowledge that other people are also human beings, right? Just like you, they will also have emotions. There will be opinions, there will be conflicts, and you must manage them all, right? You can't get into an argument with someone just because they think we only need 3 nodes for a cluster and you think that no, we need 5 nodes for a cluster. That's not a reason to get into an argument. And there's likely going to be a lot of politics as well, simply because everybody has their own agenda. So, all in all, expect there to be issues, learn to resolve them, live with them, or move on from them. But whatever you do, don't lose your mind, okay? And so that is what I would be doing if I could start all over again. I've tried to make this roadmap as detailed and as step by step as possible for you guys. I've also added it on my GitHub repository. You can visit it. The link is in the description, and you can find the roadmap here. If you think I missed something important, just comment below and let me know, yeah? And trust me on one thing, if your fundamentals are strong, you will be unstoppable. One more thing, learning all these things takes time. It doesn't happen in a month, and I'm not saying it's gonna happen in a year as well. It takes a couple of years for you to grasp these concepts and get good at them. The important thing is that you start, learn something, find a way to apply it, and then learn some more. If you improve by just 1% every day, 2 years from now, you will be in places you couldn't even think of today. So keep learning, but more importantly, get as much practical exposure as possible. Apply your skills, solve real problems, make real world impact. And then one day, you will become so good at it that you will have your own YouTube channel. Thank you for watching. I hope this video was helpful to you. Give it a like, and I will see you next time.